Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the molecular orbital energy level diagram for O2 molecule. Okay, ma. Now we are going to discuss about the O2 molecule students. What is the electronic configuration of O2 molecule? What is the bond order? What is the magnetic nature? That all I am going to discuss. Okay, na? So O2 molecule, first of all, how many electrons are there? We know that energy increasing order for the molecule students. Energy increasing order. Okay, na? In last videos, I discussed you students up to 14 electrons, one energy increasing order. After 14 electrons, another one different energy increasing order I discussed you. Okay now, so in last video students I discussed H2 molecule, Li2 molecule, He2 molecule, C2 molecule. These four molecules are belongs to up to 14 electrons energy increasing order you have to follow students. And coming to O2 molecule, this is the O2 molecule. How many electrons students? Oxygen atomic number is 8 na, so that's why O2 means 16. Total how many electrons? 16 electrons are there. That means it is more than 14, correct or not? So that's why after 14 electrons, what is the energy increasing order that you have to follow? Are you clear? Now see students, O2 molecule. So after 14 electrons, energy increasing order should follow, Nana. Energy increasing order after 14 electrons. After 14 electrons, what is the energy increasing? What is the energy increasing order? Now see students, after 14 electrons, sigma 1s less than, sigma star 1s less than, sigma 2s less than, sigma star 2s less than, sigma 2px less than, pi 2py equal to pi 2pz less than, pi star 2py equal to pi star 2pz less than, sigma star 2px. Clear? Sigma star 2px. So this is the energy increasing order students. These stars there na, stars all are anti-bonding molecular orbitals. So this without star there na, sigma 1s, sigma 2s, sigma 2px without stars. These these are these all are bonding molecular orbitals, Nana. Okay, now see students, O2 molecule. Now I am taking the O2 molecule. What is the in O2 molecule, how many oxygen atoms are there students? Two oxygen atoms are present in O2 molecule. So first I am writing one oxygen atom. Okay, now here it is having two oxygen atoms. Oxygen atom atomic number is what students? Atomic number is 8. Electronic configuration 1s2, 2s2, 2p4. Another oxygen atom also, another oxygen atom also atomic number is 8, 1s2, 2s2, 2p4. How many electrons students? Atomic number 8 means 8 electrons. So here also another atom also having 8 electrons. So total 16 electrons having. Are you clear? That means it is greater than 14. Are you understanding students? So that's why after 14 electrons this order you have to follow. Understood, Amma? So here in oxygen total 16 electrons there. So after 14 electrons this electronic configuration you have to follow for O2 molecule. Now see students, diagram. Here in the electronic configuration 1s, 2s, 2p is there. So that's a total 3 diagrams you have to draw, Nana. Okay, from down to up, Nana, I will take the diagram. See students how I am taking. First 1s I am taking, Nana. See here 1s diagram. Next 2s, next 2p I will take. So this is 1s, first one. This is 1s students. Okay, next 2s. This is 2s and 2p diagram. See here in 2p, Nana, you are taking in 2p total 3 orbitals will be there. So take here 2p. And next here what you have to take? Sigma 2px like this, and here one box, here two boxes, Next one, again here also two boxes, and next one box. See here, this is the diagram. Total three diagrams will get. This is 1s, this is 2s, this is 2p. Okay, now this all left to right to, these orbitals all are atomic orbitals. These are all atomic orbitals of carbon atom, and these middle orbitals all are molecular orbitals, and this down orbitals, down, this down, this diagram down, this diagram down, this diagram down, these down orbitals all are bonding molecular orbitals. These up orbitals are anti-bonding molecular orbitals. Now see students, this is which atom? Oxygen atom. Clear? This is one oxygen atom, atomic orbitals, another oxygen atom, atomic orbital. This is another oxygen atom. Now see here, these are all atomic orbitals, students. These are all atomic orbitals, and these are molecular orbitals, middle one. Okay, molecular orbitals. Now see students, in one oxygen atom, first oxygen atom I am taking 1s, 2s, 2p. So this is 1s, this is 2s, this is 2p. In 1s how many electrons there? 2 electrons. So take here 2 electrons. In 2s 2 electrons. In 2p 4 are there. So 2p how many electrons there, students? 4 electrons. So 1 2 3 and 4. Clear? Like this you have to, this one oxygen atom completed. Now take another oxygen atom, students. It is also having 1s to 2s to 2p4. This is 1s, 2s, 2p. In 1s 2 electrons, in 2s 2 electrons, in 2p 4 electrons. 1 2 3 4. Clear? 4 electrons there. Okay, Namma. Now see students, here these orbitals I am writing name, students. See here, this sigma, this order left to right I am writing down to up, Nana. Okay, this left to right I am writing as down to up. See here, this is which one, students? Sigma 1s. This one sigma star 1s. This orbital which one? Sigma 2s. This orbital is sigma star 2s. Clear? Sigma star 2s. Next to sigma 2px. This is sigma 2px. Pi 2py equal to pi 2pz. That means here two orbitals 1 2. This is pi 2py. This is pi 2pz. Clear? Next one, pi star 2py, pi star 2pz. This is pi star 2py. This is pi star 2pz. And this orbital is sigma star 2px. Sigma star 2px. Clear? Understood, Amma? So like this you have to take the diagram, Nana. So this is one oxygen atom. Now coming to the energy increasing order, from down to up energy increasing order. Correct? From down to up energy is increasing. Correct? Sigma 1s to sigma star 2bs. So that's why energy increasing order from down to up. Okay, now I am writing the electronic. Now see students, here in 1s 2 electrons, here 2 electrons, total 2 plus 2 4 electrons. So I am writing here 4 electrons, 1 2 3 4 filled. Now here 2, total 4. Here 2 electrons, here 2. This is bonding, this is anti-bonding. Total 4 electrons, so balanced. Here 4 electrons there, here 4 there. Total 8 electrons having. So here 1, here 1 electron. Total how many? 4 plus 4, 8 electrons. So first here 1, 2, 3, 4, 5, 6. So total 6 electrons over. Remaining 2 electrons, here 1, here 1. Are you clear? Total 8 kada. 1 2 3 4, 1 2 3 4. Total 8 electrons. Here 2, here 2, here 2. Here 1, here 1. Total 8 electrons. 2 4 6 7 8. Are you understanding? Here first bonding molecular orbitals have to fill. Remaining electrons can enter into the anti-bonding molecular orbitals. Okay, Namma? Now coming to the electronic configuration, students. How to write electronic configuration? See here, electronic configuration of O2 molecule. What is electronic configuration of O2 molecule, students? See here, from down to up we have to write. In sigma 1 is how many electrons? 2 electrons. So write here sigma 1 is 2. In sigma star 1 is how many electrons? 2 electrons. Sigma star 1 is 2. Sigma 2 is how many electrons? 2 electrons. Next, sigma star 2 is how many electrons? 2 electrons. Next, sigma 2px how many electrons? 2 electrons. Next, pi 2py, pi 2pz, 2 electrons are there. Pi 2py 2 equal to pi 2pz2. Next one, pi star 2py1, pi star 2pz1. Clear? In pi star 2py 1 electron. In pi star 2pz 2pz, how many electrons there, students? 1 electron is having. Are you clear? So here what you have to write, pi star, here I am writing Nana, pi star 2py1 equal to pi star 2pz1. Clear? 2pz1. Understood, Amma? Electronic configuration understood how to write. In sigma 1 is 2 electrons, sigma star 1 is 2 electrons, sigma 2 is 2 electrons, sigma star 2 is 2 sigma star 2 is 2 electrons. Next, sigma 2px 2 electrons. So pi 2py2, pi 2pz2, pi star 2py2, y1, pi star 2pz1. Clear? So this is the electronic configuration. Now coming to the bond order, students. Now see here, bond order, how to write? Bond order. Formula what, students? Half into NB minus NA. NB means what? Number of bonding electrons. NA means number of anti-bonding electrons, students. Number of bonding electrons, already I told you. This down orbitals all are bonding. This is bonding, bonding. This is bonding. Now anti-bonding means this up orbitals. Anti-bonding, star, star. These all stars. These are all anti-bonding. Now count, Nana, NB, how many bonding electrons are there? NB value, tell me. Number of bonding electrons, 2, 4, next 6, 8, 10. Are you clear? So total how many bonding electrons? 10. And Na value, tell me, anti-bonding, 2 plus 2, 4 plus 2. 6 electrons are there. Are you clear? So number of anti-bonding, 6 electrons. So half, then calculate bond order. Half into NB minus Na. NB is 10, Na is 6. So half 10 minus 6 means 4 by 2. That means 2 bond order. Bond order 2 is nothing but what, students? In what it indicates? Nature of the bond, what? Double bond. That means in between the oxygen atoms, Nana, double bond is existing. Clear? Bond order 2 means in between the two oxygen atoms, double bond is existing. Now coming to the magnetic nature. What about the magnetic nature? Magnetic nature. Now see here, magnetic nature, how to tell? Magnetic nature means bonding molecular orbitals. Now molecular orbitals are paired. Molecular orbitals, if suppose paired, then diamagnetic. Clear? Diamagnetic, Nana. Molecular orbitals are unpaired, that is paramagnetic. Clear? Paramagnetic. Once you see, students, here paired, these are all molecular orbitals now. Paired, but here single electron is there. Unpaired. So that's why if molecular orbitals are unpaired, what is the magnetic nature? Paramagnetic nature. So that's why O2 molecule is which nature? Paramagnetic in nature. Clear? Paramagnetic in nature. Clear, students? So this is about the O2 molecule, Nana. This is about the O2 molecule after 14 electrons. Understood, students? Okay, so this is the one example for after 14 electrons, Nana. In next video I am giving the best trick, students, best trick without this all diagrams. Directly by seeing the question only you can easily answer the question, students. Easily answer that type of one best trick I am giving, Nana, in the next video. Please don't miss, students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel. Thank you very much, students.